students. Mr. Lawrence here with your flipped lesson, and we're still working on these word problems. I know some of you don't like them, but we have to learn how to do them, and we have to learn how to do them algebraically. And remember, I've been warning you, some of you will just kind of figure these things out. You need to be able to write an algebraic expression and or equations and then solve them. All right, so I'm going to model this for you. Pardon me. In class tomorrow, you'll be doing lots of age type problems. So let's see here. Today, Bob is 4 times as old as Tim. I'm going to stop right there. I see an equation sitting there. First of all, I'm going to let B equal Bob's, not Bob's, excuse me, Bob's age. And then T, of course, is going to be Tim's age. And my first equation is hidden right here. Bob is. So Bob equals, because is means equals, right? 4 times as old as Tim. That's 4t. Now, some of you may have wanted to do this. You may have wanted to go 4b equals t. Now, I need to show you why that's wrong so that you don't do that in the future. Okay. We know Bob is the older of the two, right? Okay. If I'm trying to make their ages equal because I'm writing an equation, and Bob is the older one, and then let's say Bob is 1 year old. Well, 4 times 1 is 4. That makes Tim 4 years old. That makes Tim the older of the two. So you see this is incorrect. But if you follow the sentence here, Bob is, you've got Bob and then is means equals. 4 times as old as Tim. I need to multiply Tim's age by 4 so that can be equal. Think about it this way. Let's pretend you were 13. It's not that hard to pretend. Some of you are. And let's go back 3 years, just for my age, and pretend that I'm 39. Okay. Uh, I am obviously older than you, right? How many times? 3 times. But whose age are you going to multiply by 3 to make them equal? You're not going to multiply mine. If you multiply my age by 3, I'd probably set some kind of world record for age. All right. If I multiply your age by 3, then we end up having equal ages, or we can write an equation. Okay, so enough about that. In 6 years now, how old is Bob in 6 years? Well, if today he's B years old, then in 6 years, sorry, I want to go back to blue. In 6 years, he will be B plus 6, right? And how old will Tim be in 6 years? Well, Tim will be T plus 6. And it says in 6 years, he will only be twice as old. Well, I want these to be equal. I have to double Tim's age. Now be careful. We're not doubling Tim's age today. We're doubling his age 6 years into the future. So I need to put that in a quantity and double the entire age in the future. If I just wrote 2t plus 6, that would be incorrect because that would mean I'm doubling his age today and then advancing him 6 years, which is not the case. It's really not possible in this type of problem. Okay, let me get rid of this. Now, you don't know how to solve either one of these equations. You can't. Each one of them by themselves has 2 variables, and you can't solve one equation with 2 different variables. You could graph it and come up with all possible solutions, and I guess figure out an answer that way. But we're not going to do that. We're going to notice that B is equal to 4t. And if that's the case, I can take this 4t and substitute it into this second equation for B. Why can I do that? Because they have the same value. They're equal to each other. So I'm going to rewrite this second equation as 4t plus 6 equals 2 times the quantity of t plus 6. All right. Well, now I just have a multi-step equation. First thing I'm going to do is distribute here. And this will get me 4t plus 6 equals 2t plus 12. I don't like that there's variables on both sides, so I'm going to take away 2t from both sides. And while I'm at it, I know I'm going to have my t's on the left and my constants on the right, so I'm going to take away 6 at the same time. Now I'm running out of room there, I'm running into the next problem, so I'm going to write my answer over here, and I'm going to get 2t, the 6's cancel, the 2t's cancel, so I have an equal sign, and I have 12 minus 6 is 6, and now it's a one-step equation, divide by 2, and so that means Tim is 3 years old. Now if Tim is 3 years old, looking at this equation, that means Bob must be 12 years old. All right. Um, now let's check our answer. If Tim is 3 and Bob is 12, that is 4 times greater. And then in 6 years, Tim will be 9. I should put a T there and a B there, right? And then in 6 years, Bob will be 18, and sure enough, that's twice as old. Now, what does this remind you of? Should remind you of a T table with X values and Y values, right? All this stuff we're doing is the same as stuff we've already done. Had we done the graphing like I suggested, that wouldn't really be an efficient way to do it, we would have come up with a 0.918 on our graph. Okay, now it might have taken a little while for us to get there, but we would have come up with it. Okay, one more example, and then I'll let you go for tonight. Today, Sally is twice as old as Beth, so I'm going to let S equal Sally's age. Now that's today. I mean, on last problem I assume that, but I guess I should write that in. And then B is going to equal Beth's age today, right? And I have my first equation. I know Sally is twice as old as Beth. Okay? 12 years ago. Well, how old is Sally 12 years ago? If today she's S, then 12 years ago she's S minus 12. That makes Beth B minus 12. And it says 12 years ago she was 3 times as old as Beth. So to make them equal, I have to triple Beth's age in the past. Okay? Now, again, I don't know how to solve one equation with two different variables, but I know that S equals 2B, so I'm going to take this 2B and I'm going to plug it right in there in place of S. So my new equation will be 2B minus 12 equals 3 times the quantity of B minus 12. And this is done very much the same way as the last problem. I'll begin by distributing. Okay, and I'll get 2b minus 12 equals 3b minus 36. Then I'm going to subtract 2b. All right, get negative 12. We get b minus 36. Okay, add 36. I could have done that on the last step. I was slightly distracted, but that's okay because I can still model it this way. Those are going to cancel. I'm going to get Beth is 24. Well, let's see here. If Beth today is 24 and Sally is twice as old, right? That makes Sally's age 48. Okay. 12 years ago, Beth would be 12 and Sally would be 36. And sure enough, that's times 3, isn't it? There you go. All right. The trick is being able to define your variables and then writing equations from the sentences. All right, that's it for today, everybody. Mr. Lawrence signing off. Good night, everyone.